Welcome to the conveying system types. You see that previously we were discussing about the various modes of pneumatic conveying. We discussed about the basic philosophy of the pneumatic conveying. We discussed about the dilute phase, dense phase, conveying air velocity, solid loading ratios, etc. in the previous lecture. We had a discussion about the advantages and disadvantages of the pneumatic conveying system. Apart from this, the main components of the pneumatic conveying system. In this particular lecture, we are going to discuss about the different types of system, closed system, open system. Then we will discuss about the batch conveying system, semi-continuous conveying system. We will discuss about the single plug systems and innovatory systems in fluidized motion conveying system. So, let us talk about the type of pneumatic system. When we are discussing about the system types, the different type of pneumatic conveying systems are available as on date with which are suitable for conveying dry bulk particulate matter. The majority of the systems are usually conventional, continuously operating system, open system in a fixed location, etc. So, depending on types of material conveyed, innovatory batch operating and a closed and open type systems, they are commonly used. Now, here you see that different type of pneumatic conveyance system. There are two different type of system, one open and closed system. So, if we take the open system in question, then again you can classify into the combined one, negative pressure, then positive pressure type of a system. Now, if we say that the combined one or combined negative pressure, then there are continuous and a low pressure type of a system. Similarly, if we talk about the closed system, then again they are having the negative, positive, and if we see the positive pressure system, it is having the continuous type of a system with a very low and high operating pressure scenario. Similarly, if we talk about the open system with the positive pressures, it can be classified in the two mode of operation. One is the continuous and second one is the batch one. Now, this batch is again, if in terms of we classify, subclassify with respect to the operating pressure, it can be either high or a low one. Now, the pneumatic conveying system, their requirement, they are usually the source of compressed air. That is the foremost requirement, and we can understand. Usually, we are using air under the gaseous media. We must have a feed device, a conveying pipeline, a receiver to disengage the conveyed material, and a carrier gas, etc. Apart from some allied systems. Now, the system is completely enclosed. It may work completely without moving elements coming into touch with the conveyed material if necessary. If we are using the hygroscopic materials, then obviously we need to use the dry air, and if we are looking for some inert gas, then nitrogen is the best option for this. The material can be transported using high, low or a negative pressure. That depends upon the circumstances or the process in question. Now, let us talk about the open system. Now, when strict environment control is not necessary, then open systems are preferred. The capital cost of the plant and operational complexity will be reduced, and therefore, a wide range of systems will be available. Now, with the suitable gas solid separation and venting, a number of materials can be handled safely in an open system. Many potentially combustible materials, they are conveyed in open system by incorporating necessary safety features. We have already discussed various safety features in previous lectures. It may be classified further into positive and a negative, combined and dual pressure conveying system. So, let us talk about the positive pressure system. The positive pressure conveying systems discharging to a reception point at the atmospheric pressure, they are most common conveying system. The feeding of the material into the pipeline with the positive pressure air it creates a number of problems. Now, with the use of diverter valves, it is possible for multiple delivery to a number of reception points by using positive pressure system. Now, multiple feeding points sometimes into the common line, this can also be arranged, but care must be taken particularly in the case of a rotary valve feeding pipeline. Air leakage through these type of valves can be quite significant in the relation to total air required for conveying. Now, here you see the positive pressure system. Now, you are having one supply hopper through which it is being conveyed. There are diverter valves, and these are the discharge hoppers, and all these systems are equipped with the filters. Now, let us talk about the negative pressure system. Now, vacuum systems, they are commonly used for drawing materials from a multiple source to a single point. There is no pressure difference across the feeding device, so multiple point feeding into a common line presents several problems which need to be addressed. Rotary valve and screw can also be much cheaper item for feeding a pipeline in a negative pressure system than in a positive pressure system. The filtration plant has to be much larger as a higher volume of air has to be filtered under vacuum condition. Particular care must be taken when specifying these type of particular components. Negative pressure systems, sometimes they are also widely used for drawing materials from open storage where the top surface of the material is accessible. Like this, here you are having a heap of coal and then you can carry out. They are also particularly useful for cleaning processes such as removal of material spillage and dust accumulation, etc. If a very high vacuum is used for conveying of a material, consideration should be given to the stepping of a pipeline part way along its length. Now, if the pipeline is not stepped, extremely high values of conveying air velocity can occur towards the end of the pipeline. The situation is usually same for a very high pressure positive pressure conveying system. The vacuum systems have the particular advantage that all gas leakage is inward. Like here, you are having this vacuum system, and in case if any kind of a leakage is there, because you are having the vacuum over here, and here this is the high pressure zone and it is the low or negligible pressure zone, then obviously the material or the leakage will be inward, so that the injection of dust into the atmosphere is virtually eliminated, because nothing will go out. So, any kind of contamination to the outside atmosphere is virtually eliminated. This is important for the handling of toxic and explosive material or any material where environmental challenges have to be taken into consideration. It is not always necessary to employ a closed system with these materials, therefore provided that adequate safety measures are taken, and particularly with regard to the exhaust venting. Now, it is also essential that exhauster should be protected from the possibility of the failure of one or more filter elements in the gas solid separation system. Now, here you see that this is the negative pressure system. Here you are having some stockpiled, and because of vacuum, this material is conveyed through this pipeline with the help of this suction nozzle. You are having this flexible hose. Now, here you are having this receiving hopper, and this is an exhauster equipped with the filter. Now, there are some certain negative combined negative and a positive pressure system. Now, the protection has to be provided for the exhauster or a blower from the possible ingress of material as with the negative pressure in a closed loop system. It should be noted, or it should be given a due consideration, that the available power for the system has to be shared between the two sections, and that the pipeline for the two parts of the system have to be carefully sized to take into account of different operating pressures. Now, some air movers like positive displacement blowers operate on a given pressure ratio, and this means that the machine will not be capable of operating over the same pressure range with the combined duty as compared with their individual operation. Now, here you see the typical figure of a combined negative and positive pressure. Here you are having the storage hopper with the help of a vacuum line. Now, here you see that it is equipped with the filter and a diverter. Now, here you are having this exhauster and a blower. With the help of this can be disengaged. Now, apart from this, there are dual vacuum and positive pressure system. Now, if the conveying potential of a system requiring the vacuum pickup of material, it needs to be improved or improvised beyond that capability with a combined negative or positive pressure system, whether in terms of conveying distance or material conveying rate, then a dual system should be considered. It is the good candidate to be considered. In this combination, the two conveying elements are separated and two air movers are provided. Now, as two air movers are provided, this means that the most suitable exhauster can be dedicated to the vacuum system, and the most appropriate positive pressure system can be used for onward transfer of material. Now, if the vacuum offloading section is only a short distance, it is possible that material could be conveyed in a dense phase over the entire conveying distance. Now, with a high vacuum exhauster, a material such as like cement, it could be offloaded at a rate of about say 900 to 1000 tons per hour through a single pipeline. Sometimes twin vessels on quasi site would allow continuous conveying to shore based reception vessel, which could be some say 2000 feet distance if a high pressure compressor was to be used. Now, here you see the dual vacuum and positive pressure type of a system. You are having this suction nozzle and exhauster, always having a compressor with it. Through this exhauster you are supplying to these intermediate vessel, and here you are having the reception silo or reception arena. Let us talk about the batch conveying. Now, all the system which we described previously, they are considered they are capable of continuous conveying. In many processes, it may be more convenient to convey one batch at a time. Now, these conveying can either be carried out on a continuous basis or in a sequence of isolation batches. The majority of batch conveying systems are based on blow tanks, and the blow tanks are chosen either because of their high pressure conveying capabilities or because of the abrasive nature of the material. Two types of systems they are usually considered. First is the semi-continuous system, in which the batch size is relatively large and the material is fed into the pipeline gradually. The other material is fed into the pipeline is a single plug. Now, here you see the typical batch conveying system based on single blow tank. Here we are using the blower or a compressor. This is the blow tank. You are having the storage hopper with this conveying line, and you can collect the material over here with an associated filter. Now, if we discuss about the transient nature of the batches with respect to the time versus material flow rate, at the start the material is on the top, and then it acquires the stagnant value over the period of time, and thereafter it completes one cycle. Now, let us talk about the single plug system. Now, in single plug system or conveying system, the material is effectively extruded into the pipeline as a single plug. Although material is generally well aerated, it is usually 30 feet long. The plug is then blown through the pipeline as a coherent plug. Now, a certain amount of material will tail off the end of the plug as it is conveyed, but the front of the plug will sweep up material deposited in the pipeline by the previous plug. The air pressure has to be overcome the frictional resistance of the plug of the material in the pipeline. Now, as a result, blow tank size are rarely larger than 150 cubic feet unless very large diameter pipelines are employed. The pipe diameter is usually selected such that the frictional resistance of the plug results in a reasonable air supply pressure to propel the plug at a given velocity. Now, single plug systems, they are capable of conveying a wide range of materials and generally at much lower velocity than it can be achieved in continuously operating systems. Although the plugs of materials they are conveyed at a relatively low velocity, once they are discharged from the pipeline, the high pressure air released behind the plug can cause several erosionic options in the plug pipeline during the venting. Now, here you see the single plug system. You are having the air supply equipped with the blow tank. We are having the supply hopper with the vent, and this is the conveying line, and usually with the help of the filter we are having this discharge hopper. Let us talk about the closed system. Now, it is employed for higher toxic and potentially explosive material. So, this is one of the added benefit. Nitrogen or other gases, they can be used to convey the materials. The gas in a closed system can be recirculated, and so the operating costs are significantly reduced. For toxic and radioactive materials to be handled, it may use air for conveying with maintained very strict control. The continuous conveying system is probably the most easiest way to arrange in the closed loop. Now, here you see this is the closed loop system. We are having a backup filter over here with apart from this primary filter, and so as usual we are having the supply hopper, and a blower is attached to somewhere here, and the it is equipped with the heat exchanger. Now, a null point where the pressure is atmospheric needs to be established. Now, if it is located before the blower, it will operate as entirely under vacuum. Now, if it is located before the blower, it will operate as a positive pressure system. Here you see in this figure. Now, heat exchanger can be used, here you are using the heat exchanger. The heat exchanger can be used to remove the increase in the temperature across air mover, and it can be placed either before or after air mover depending upon the material to be conveyed. Now, let us talk about the innovatory systems. Conveying materials with no natural dense phase conveying capabilities at a low velocity. The innovatory systems produced as a result of these developments, they have centered around some form of conditioning of the conveyed material either at the feed point into the pipeline or along the length of the pipeline. Since the modifications are essentially based on the pipeline, types of conveying systems have not changed significantly. Let us talk about the plug forming system. The pulse phase system that was developed way back in 1960. It was based on the use of a bottom discharge blow tank feeding material into a pipeline. The air is supplied to the top of the blow tank to pressurize the system to aeration rings near the bottom of a blow tank and air knife at the start of the conveying line. Usually we have timer switches. So, a timer switches the air to the knife on and off are the predetermined frequency. So, when the air supply to the knife is on, the air pulse splits the material in the pipeline and it stops the flow additional material from the blow tank and pushes the severed plug a short distance along the pipeline. So, when the air to the knife switches off, the material again flows from the blow tank past the knife and cycle repeats itself. No further conditioning of the material occurs along the length of the pipeline. The pulse phase system was initially proposed as a solution to the problem of conveying cohesive bulk solids, but subsequent developments have shown that a wider range of materials can be conveyed successfully. Now, with the impermeable materials, it has been found that the pressure drop increases exponentially with the plug length, but by splitting the material into the short plugs separated by air gaps, the overall pressure drop can be reduced considerably. Now, here you see the innovatory system. You are having the supply hopper. If you compare with the previous figures, the blow tank is having this pressurized air and fluidized air is also supplying to the bottom of this blow tank. Here we are having this air knife with the help of a pulse air, and as usual we are having one discharge hopper. Let us talk about the bypass system. The most common bypass systems employ a small pipe running inside the conveying line, having fixed ports or flutes at regular intervals along its length. Now, this inner pipe is not supplied with an external source of air, but air within the conveying line can enter freely through a regular opening provided. In an alternative design, the bypass pipe runs externally to the pipeline and interconnected at regular intervals. Now, if the material is impermeable, the air will be forced to flow through a bypass pipe if pipeline blocks. Now, this showing the various bypass line like internal bypass, external bypass and internal bypass. So, the bypass pipe may run continuously when external to the pipeline, but the internal fluted pipe is generally confined to a straight length of the pipeline. Now, because the bypass line has much smaller diameter than the pipeline, the air will be forced back to the pipeline through the next and subsequent because of the extremely high pressure gradient, and this will affect the breakup of the plug of material causing the blockage. Let us talk about the injection systems. The number of systems have been developed that inject air into the pipeline at regular point along its length as per the figure which we have described. Now, while the bypass pipe system artificially create permeability in the bulk material, air injection will help to maintain a degree of air retention within the material. Continuous injection of air into the pipeline, however, it does not mean that conveying air velocity towards the end of the pipeline will be much higher as a result. Now, here you see the different type of plug control system like external bypass, internal bypass, porous tubes, you see, and the booster lines, etc. In some systems, sensors are positioned between the parallel air lines and conveying pipeline, and air is only injected when needed. Now, if there is a change in the pressure difference between the two lines is detected, which would indicate that a plug is forming in the conveying pipeline. Air is injected close to that point in order to break up the plug and so facilitate its movement. With most conventional system, it is not possible and would result in considerable inconvenience in cleaning pipelines if a blockage occurs as a consequence. Since they are capable of conveying materials in dense phase, operating cost for the power is likely to be lower than those for a conventional dilute phase system. The capital cost for the innovative system are likely to be higher. However, on an economical assessment of alternate system would need to be carried out while using such type of a system in practice. Now, let us talk about the fluidized motion conveying system. The categorization of the fluidized motion conveying system always represents a problem. They are not generally recognized as a pneumatic conveying system because they only use very low positive pressure air. The material does not flow through a pipeline and they have been limited to a flow down gradual inclinations only. They are, however, clearly not in the mechanical conveying group of conveyors. Until recent years, their application was relatively limited because the main driving force was gravity, and so they would only operate on downward inclination towards at a very low angle. The material is usually conveyed along a channel that has a continuous porous base. Air enters the material through the porous base and fluidizes the material. The fluidized motion conveying system is classified in two broad categories. One is that air assisted gravity conveyors and second is the full channel conveyors. Now, air assisted gravity conveyors, in situation where the flow of material can be downward, the air assisted gravity conveyor has a number of advantages over a pneumatic conveying system. The plant capital cost, it can be much lower, operating costs are significantly lower and a wide range of materials can be conveyed at a very low velocity. Here you see this is the air assisted gravity conveyor. We are having the supply hopper with the air, and here you see in a section wise manner you see this the side view. We are having the plenum chamber, porous membranes is situated here, and this is the conveying channel. A small quantity of low pressure air is fed through the membrane here, through this particular membrane. The inner particles and a particle wall contact force, it can be reduced and the material will behave like a liquid. Now, if a slight slope is imparted to the conveyor, the material will flow as per the figure which as per this figure. Now, in general, most material in the mean particle size and density ranges from say 40 to 500 micron and 80 to 300 pounds per cubic feet are the easiest to convey and will flow very well down shallow slopes. Now, as we talk about the full channel conveyors, the pressurized horizontal conveying system developed by aluminum machinery to convey alumina. The alumina was conveyed from a single supply point to more than 100 outlets. Electrolysis pots on a modern aluminum smelter, they were required to be filled and the distance from the silo to the furthest outlet was approximately 600 feet. A conveying channel is employed as with the air assisted gravity conveyor, but the channel runs full of material. Balancing columns, they are positioned on the conveying ducts and are used for redusting. This is not a continuous operating system in the application described. If it is a batch type of a system and its objective is to meet the demand of intermittent filling of the pot hoppers. The system, however, is clearly capable of continuous operating conditions and significant further development. Here you can see this fluidized motion conveying system. This is the potential fluidized ducts, supply hoppers equipped with the fans, and this is the dedusting duct. Apart from this, we are having the pot hoppers. So, in this particular lecture, we discussed about different type of conveying systems. We described all different type of conveying system which are used in practice. And for your convenience, we have enlisted 4 different references. If you wish to have a further study, then you can use these references. Thank you very much.